So if it's okay with you both, I think we can get started.
Hey.
So hey everybody, welcome. So few quick things. So this is Remo. We've been using it for the last 2 days. Just a quick thing on tech issues. First thing you should probably try is just to refresh your page. But otherwise, I am tech support. So if you need anything, just feel free to send me a private message or come find me in the rooms. So my name is Terry Busk. I'm with the American Institute of Mathematics. And I have the pleasure of introducing our speakers today. So we have Fred Peck from the University of Montana and the Montana MTC. We also have Nick Grener from Hellgate High School, also from the Montana MTC. And I'll leave it to you guys to take it away.
Cool, right on. Thanks a lot, Terry. Yeah, hi everybody. Hey from Montana. So I'm Fred, and here's Nick.
Hey. Welcome. Thanks for being here.
Yeah, we're super excited. So we're gonna play this game called the Game of Cycles. Nick and I are gonna play it a couple times, sort of publicly to sort of get the rules down. But before we do that, if you could just take a look at the rules. So if this is your first time using Remo, you'll notice that there's sort of 3 screens: my face, Nick's face, and then a slide that says Game of Cycles. That slide might be really small depending on your computer screen, but you can make it bigger by clicking the arrows in the top right corner of that slide. So if you can't read, so that slide has the rules. It's a super simple game. If you can't read the rules yet, because it's too small, just click the arrows to make it full screen, and then you'll be able to see it bigger. So just take a moment and read the rules. Then Nick and I will play a couple games, and then we'll talk about any questions that you have.
And you don't need to worry about memorizing these rules. Fred's going to keep this slide available throughout the session, so you can always refer back to these.
Yeah.
You forget something?
Yeah, so maybe we should just play a couple games. Should we do that, Nick?
Yeah, sounds good to me.
All right, so, okay, so now you should all see 4 screens: our faces, plus the Game of Cycles slide, plus a whiteboard that's loading. Just like before, if you want, it'll be helpful, I think, if you make the whiteboard full screen so you can watch us play. So go ahead and make the whiteboard full screen if you can. And what you'll see is there's a bunch of cursors running around like crazy. For whatever reason, we can't turn those cursors off. So what would be helpful, if you could, is if you could please move your cursor to a corner so that it's not sort of in the middle of the whiteboard, and then kind of leave it there. That means, like, don't use your mouse, I guess, for a little while we play this game. Yeah, we'll just play a couple games on this shared whiteboard, and then yeah, we'll talk about any rule questions that you have.
Okay, so the game starts with a simple planar connected graph of your choosing. So we're going to just start our first example game here. Fred and I are just going to play on the sample board that you saw in the instructions. So I'm going to draw something equivalent to the sample board you saw in the instructions. So you should be able to, if you move the screen around, you should be able to see basically a box with an X in it. Can somebody in the chat just verify that you see a box with an X in it?
Cool. Yeah, it looks like people can see.
Great. Okay, so the purpose of the game is to take turns putting arrows on the board on one of the segments. So it's important to note that anywhere you see segments cross, there's a vertex. So I'm not going to draw vertices in here because it will get a little bit sloppy. The pen tool in this whiteboard isn't the greatest, but you're just going to assume a vertex at each meeting of segments here. So we got 5 vertices on this board, and there's a total of 8 segments, it looks like. And Fred and I are just going to take turns putting an arrow on one of the segments. And the winner is going to be either the first person who creates a cycle around one of the 4 small cells there, or the last player to make a legal move. Okay, Fred, do you want to go first, or should I go first?
Yeah, I'll go first. So
Okay,
I'm going
go for
to
it.
draw an arrow right there.
Okay. All right, I'm going to go up here.
I'll make my pen a bit bigger. All right. So let's see. I'll do that.
Okay, it's important to note now that there's 3 arrows on the board, and those arrows belong to both of us. It's not like the 2 arrows that Fred drew are Fred's arrows, and the one that I drew is my arrow. Those are both our arrows. So I see this cell here on the right that's got just needs 1 more arrow to complete a cycle. So I'm going to complete that cycle, and I guess I'll shade it in as a little victory march here. But since I created a cycle around this cell, I'm the winner of that game. It's pretty straightforward in that, I mean, we played a kind of a, Fred kind of handed me one there, didn't you, Fred?
I thought I was being strategic, actually. I only realized later on.
So an important thing to note here is that Fred and I are by no means experts on this game. When we do our circle in Missoula, Montana, we take turns. Each session, a volunteer brings a puzzle or a game or a problem of some sort to the session that they're not an expert in. So we don't really have we're in presentation mode right now with all of you, but this is, you shouldn't think of this as we're presenting and you're receiving. We are almost as novice at this game as you are. We've played, I don't know about you, Fred, I've played for about 15 minutes, half an hour maximum. So we by no means have the answers here. And in fact, once we break out into tables, we're hoping to jump around tables and maybe get a chance to play with some of you all and see what you're thinking. But before we do that, let's do one more game, and then we'll see if there's any questions, and then we'll break you out and let you start exploring with this game. Does that sound good, Fred?
Yeah.
Okay. I'm going to go, or do you want to draw a board?
Yeah, I'll draw a board.
Okay.
So okay, I'm going to draw it right below, and
Okay.
notice you can, other people, everybody who's here, notice that you can move around the whiteboard by selecting the hand or the pointer tool on the left-hand side, and then clicking and dragging. So I'm going to draw the board right below. I'm going to draw just a square. No, I'm going to draw a pentagon with one single line going from there to there.
Okay.
There we go. So now we have
a legal board to me, yeah?
Yeah, six edges. And let's see, it looks like there's 1, 2, 3, 4, 5 vertices.
That's right. And there's just 2 cells there. So one of us has to capture one of those 2 cells.
Yeah, so you can go first, Nick.
All right. I'm going to take the middle segment here.
Seems like a good strategy.
I probably said that wrong, though. I shouldn't say I'm taking that segment, because I'm not, right? I'm just putting an arrow on that segment.
Right.
That arrow belongs to both of us.
I'm going to do that.
Okay. And so now, according to the rules, if I want to draw, so we have something close to what's called a sink developing here at the top left vertex. We have 2 arrows pointing at it. So I am allowed to draw an arrow on this leftmost segment, but if I choose to do that, I got to go down, because you're not allowed to have any vertex sinks on the board. I'm not going to go down here because I see that Fred would then be able to complete the cycle at the bottom segment. So I'm going to choose something else to do. I'm going to go over here.
All right. And I noticed there's a couple of questions in chat. We'll play this last game, and then we'll talk about whatever questions there are in the chat.
Yeah.
All right. So yeah, let's see. If I go here, so here's a move that I'm not allowed to do. I'm just going to do it, but let's talk about why I'm not allowed to do it. So that arrow I'm not allowed to draw. And the reason why is because then this bottom right vertex would be a source. Everything is coming out of it. So you can't have a vertex where all the arrows are going out or all the arrows are going in. So the arrow that I just drew is illegal. So I'm going to undo that arrow. And I'll draw one. Let's see. How about right there?
Yeah.
There we go.
I think, yeah, and you had to draw it that way, right? Because if you drew it pointing the other way, then both this vertex down here would be,
that would have been a sink.
And this would have been a source. So you, once you decided you didn't, I already kind of made an argument for not drawing on the left-hand side. You made an argument for not drawing on the bottom segment there. And so you were stuck with this segment and you were stuck with one move.
Yeah.
So now it's my turn, huh?
Yeah, I'm afraid so.
I'm afraid so, yeah. So one of the rules of the game, maybe, I don't know, if, I can't see the chat right now, but a natural question that comes up is, so I don't want to make a move right now because every legal move I have will let Fred win on the next game. But if you have a legal move available to you, you have to make it. So I either have to draw on the left segment here, in which case I have to draw a down arrow, or I have to draw on the bottom segment and draw a right arrow. So I'm just going to do that and concede that Fred is going to create a cycle there on his last move.
Yeah. And it's, even if I couldn't make a cycle, as long as I could draw an arrow there, I still would have won because the object of the game is to either make the last legal move or to make a cycle. In this case, I did both, but
that's right. That's right.
It happened to make a cycle this last
Yeah, but
time.
you can't claim that you're a double winner or something like that, Fred. That doesn't.
Oh, I can claim whatever I want. That seems fair to me. All right, so there's a couple. There's a couple examples. Let's take a look at the chat and see what questions there are. Okay, so let's see. So Terry asked, can you write arrows in different directions? So the arrows can be in different directions, but once a segment is arrowed, once a segment gets a direction, that's it. That's the direction for that segment. So you couldn't like write an arrow on the same segment in a different direction.
That's right. Mark wrote, does it not matter that two arrows are pointing towards the bottom right vertex? Somebody else wrote, somebody else here is encouraging 3 people to be at a table. And we were going to encourage having either 3 or 4 people at a table.
Yeah, 3 or 4 people at a table.
Yeah, so I assume in that question about the bottom right vertex is probably referring to the first board here, and that's okay to have 2 arrows pointing at it because the third one's pointing away. So it's not a source or sink. I mean, it's not a sink.
Yeah, so it's yeah. Basically, every arrow has to. You can't have a vertex where every arrow is pointing in the same direction, but you could have a vertex where some of the arrows are pointing in the same direction and some of the arrows are pointing in a different direction.
Okay.
Yeah.
A couple good questions here. Wasn't a 4-sided. I see some hypotheses and sort of hypothetical questions that are worth exploring that I'm not going to address. Not only because I don't know the answer to them, but also because I don't want to spoil any fun for anybody else. Somebody wrote, I missed why you drew a pentagon. Fred, why'd you draw a pentagon?
Just because I wanted to. So you can draw any kind of board you want, basically.
Yeah, the legal board, the definition is a simple, planar, connected graph. So it has to be one piece. You can't have any loops, just like a loop coming out of a vertex. So you have like a set of vertices and they're connected by segments or not connected by segments in some case. At that last board that Fred drew, we had some vertices that weren't connected to each other, but that was still a legal board.
Yeah, you basically just have to, like, there has to be a path to go from any vertex to any other vertex. So you can't have like a stranded guy out here.
Yeah.
Right. It just has to be connected. And by the way, that's a thing you can change. You could play around, right? So these rules are not like handed down to us. They are handed down to us, but they're not fixed. So, so I drew a board that looked interesting to me, but you can draw other kinds of boards as well.
Yeah. One last question was, did I create a 4-sided cycle cell in that last game? But the 4-sided cell, if you open up the whiteboard and look at the cell on the right down there, it's not a cycle cell because 3 of the arrows are pointing in are pointing counterclockwise, but 1 arrow is pointing clockwise. So it's
What
not.
about a 5-cycle cell? Maybe I created a 5-edge cell. Did I do that?
Okay. Oh, like all the way around. So that wouldn't be. That's a good question. That doesn't count as a cycle around the perimeter because it's not enclosing a single cell. So a winning move has to enclose a single cell with a cycle. Yeah. All right. I say we break out. Let people.
Yeah. So at this point, we're going to put everybody in tables. You're just going to be assigned randomly to a table. But if you're familiar with Remo, you know that you can go to other tables if you'd like. And if you're not familiar with Remo, what you'll notice is that there's tables and you can just double click on a table to move to it if you'd like to move there. And what we encourage is, let me just put that up. This is just creative time. So we'd like you to play the game, ask mathematical questions about the game. We've already seen some of those in chat. Investigate those questions. You could make modifications to the game. This is just open-ended sort of mathematical playtime now. But we do have a gallery, and notice that link at the bottom there, bit.ly/mtc-cycles. We hope that as you're working in your tables, not everybody will be able to see what you're doing. So if you could share interesting things that you're coming up with in your tables, like questions that you're exploring or approaches or strategies or findings, anything you'd like to share, please put in that gallery as we go along. And we're just going to be in our tables for about an hour as we play around with this game and ask and explore mathematical questions.
Yeah. The winner is, one last question came in. The winner is whoever completes the first cycle, and if no one is able to complete a cycle, it's the person who made the last possible legal move. So you're just trying to create the first cycle to win.
Right. First cycle or last move. Those are the two ways to win. And if you go to that website, bit.ly/mtc-cycles, there's a link to the full rules so that any other questions that come up, you'll be able to answer by going to the rules, or you can always put it. All right, should we do it?
Yeah.
All right, I'm going to turn present off. Is that how I do it?
Yeah.
Yeah, right on. Have you guys been in Remo before? Do you know how to work this sort of zone?
Yeah. Unfortunately, I have to, if I use the whiteboard, I'm writing with the mouse, but I could tell that's what you guys were doing too.
Yeah, right. we thought this game was crude enough.
That works real well for this particular activity. That's fine for.
Yeah. Yeah, I'll join the whiteboard.
Yeah, we're gonna have to use it. I know there's a way to draw like polygons, or at least a square or a rectangle, but I'm not sure if you can draw any polygon on here. This is my first week using Remo, but
yeah, mine too. I've used it a few times, but
I got too used to Zoom.
Yeah.
Right.
There's shapes, so you can choose like a rectangle or a pentagon or other 4-sided shapes. I guess if you want to go more than 6 sides, then you'd have to draw it.
Gotcha. There, I just made a. Yeah. Well, should we did you guys think of some questions you want to explore, or do you want to play the game a bit, or what should we do?
Probably play the game a little bit just to see how it.
Yeah. Do you mind if I let you two play the game just so you get the hang of it? And then,
Sure.
like Nick said, I don't know what I'm doing any more than
That's
you
fine.
do, but you may as well. Maybe you guys can play a couple, 1 or 2 versions, and then.
Oh, that's an arrow. I don't want that. How do you delete?
There's an undo.
So you
down.
said you want it.
I think the arrow
you
is
said
right
a
next to the 100%.
any shape. But like it'd be boring to just do a regular polygon without lines through the middle in some way.
Yeah, it's interesting though. I mean, I wonder if.
Because it would be pretty straight. Well, I don't know.
Well, we could start with something that simple and just try to see what the strategy would be to solve it completely. Like, who's going to win? Does it matter whether you go first or second?
Yeah. Okay. Then let's do one of these quadrilaterals. They'd be the same game, basically. And then we could try something different for the second one.
Okay.
You want to go?
Sure, why not? I guess if there's these, it really doesn't matter what I do for a first move.
I don't think so.
I thought I clicked on my pen. Let's try that again.
Okay. So like if I make one move that goes against this, then it would be the last legal move. But
Well,
I can't go against, like I can't do an arrow like down because then sink.
Right.
So I'd have to do a move that followed suit with what you did.
Or you could do the top.
Or I could do the top different. Yeah.
Yeah, but if you did either the left or the right, you could only draw the arrow in right.
But if you go, so if you were doing it, what would happen if you, that's what I was going to ask. What would happen if you did that? Because right now you just won because you made the last, no, not yet. Wait, nope. Yeah, I can't do.
I think she did, yeah.
Yeah, so the game's over.
I think she just won.
Oh, okay.
Because I can't go either direction on either of those sides because I'll have a source or a sink.
Yeah. So if it's a 4-sided polygon or quadrilateral without any segments in the middle, the second person can always win.
Right. Yep. All right. So what if we had a triangle?
I don't know. I mean, I'm a visual person, so some people might be able to talk through it, but it helps me to see
Let's
sometimes.
see. So I'll just make a move because it doesn't matter on the first move if you don't have sides in the middle.
Yeah. So yeah, like I can't go opposite on either one because it's connected to that segment. So I'd have to follow suit. I'd have to.
Right. So in this case, so then I win by making the last move and by making the cycle.
Mm-hmm.
So triangle. Once one person makes a move, it's deterministic.
Yeah.
Yeah.
I mean, the second person gets a choice about which segment to draw the arrow on, but
they don't get a choice in winning.
Right.
And actually there you don't even have to be strategic.
Yeah.
So if you did have pentagon, I'll let you go first this time since I went first the last two.
Okay. Is the first move arbitrary? Like
since we don't have anything cutting through the middle, I think it is arbitrary.
Yeah.
Right. I think so too.
So I could go up here only if I go in one direction. I could go here only one direction. So I can go either direction on these others. So let me just pick, I'll just pick an option and then we'll see what happens.
Okay. So yeah, now I can't do this top one because if I go with this arrow, then it's a sink. And if I go opposite, then that one, the other vertex is a sink.
Right.
So I can either follow suit on this one or follow suit on this one. I wonder if that would matter. I don't think so. I'm just going to do this one.
So if you do that, then you just
Then she
won.
just won, right? Yeah.
Now,
So I wonder if there's odd sides, because in the triangle and in the pentagon, the first person won.
right, but we didn't exhaust all the possibilities yet. But I don't know that it makes a difference. Like, what if I had gone the opposite direction on that same arrow? Or what if I had chosen to go in the flow
Yeah, right.
on the 2? So I'm going to undo mine. If you'll undo just one of your moves, then I will.
Oh, yeah.
Okay, so
Okay.
what if I had gone, let's say right here.
Okay. So, I mean, yeah, I could follow suit, you would follow suit, and then I would win if we all followed suit the whole way and just didn't
Right.
play, basically.
Yeah.
So let's think if I chose this other one and went opposite.
Yeah, because if you follow suit, you would have to win, right, Jessica? I mean,
Yeah. Because if I followed suit, like it wouldn't matter which segment he chose, he would have to follow suit as well. Otherwise,
Yeah.
he'd create that sinker source.
right. So I think that
So
top
that way,
right is impossible to use right now, right?
right, and so is the bottom one.
Oh, yeah.
Mhm. So the first person won again.
Right.
So I'm putting that out there as a conjecture.
What did we? So we done? Yeah. Have we done enough to prove it yet? Let's see. I can't remember what did we do. Is this our third case or just the?
This is the second case of an odd number of sides. That's, yeah, my conjecture is an even number of sides, maybe the second person would win. And an odd number of sides, the first person would win. But no, I don't think we've done enough to determine if that's true.
Right.
I don't know. I don't think.
Okay, so I'm gonna get rid of that one. Did we do both directions on that top
Yeah,
right
we didn't
side?
do the other direction on that. Yeah.
Do you
I
want to
can't
try
remember.
that?
Sure. I can't remember which direction I even went the first time.
You went opposite of what it should.
Okay, so if I did that instead, so would
So
that
if you
have
did that instead, then I could follow suit here, here, or here. But no matter what, I would have to follow the pattern because I
And then
can't go opposite.
right, and then I
and
would
be
have to
placed.
as well. Yeah.
And then you'd have to, and then I would have to, and I would win.
Okay. So both directions there. So that takes care of, even if I went on this side on the right and did both, that's the same case as
Yeah, it's
what
the
we've
same,
just
right?
done.
Yeah.
All right. So I think you're right so far. I think we've exhausted all the possibilities on the pentagon. Do we want to
Yeah.
keep going with this another time, or do we want to start putting lines down the middle of something?
I think it's, I mean, like a 7-sided figure is much more complicated, right? It's a lot more cases.
Yeah.
But the conjecture, Jessica, your conjecture is that odd would be player 1 winning and even would be player 2 winning.
Yes. With at least these open polygons without lines. I don't know if that would change once we start adding lines in the middle. I would It could, or it could surprisingly not.
Yeah, do we want to try a hexagon or a 7-sided or a heptagon?
Yeah.
Mhm.
Which one do you want to do? I don't know if I can draw.
They have a hexagon shape that's already built, so we
Oh, well,
could
then
do
let's
that
do that.
and test
Let's
the
do that.
even instead of having to. It's hard to draw shapes on here. My computer keeps moving it,
Okay, so I need to move my,
and you can move the whiteboard around, which is kind of cool. But
yeah. Okay, so you say you want to go second. All right, so I'll let you go second.
okay. If I want to win, I want to go second. That's my
Right. Okay, so there's my move.
okay. So I can follow suit. I'm gonna try to go with this top one and go against the current.
Okay, so if you do that, then I can't do anything on that upper left side. So I'm going to do that.
Okay. And then I could follow suit here.
Right.
That's the uglier, but yeah.
And then I can't do anything.
And then I would win.
Right.
Yeah.
Yep.
So
And it
Justin,
didn't
you were
matter if
player
I
two?
chose that side, it didn't matter if I went the other direction because it was a similar case as the other. It was isomorphic to it.
Yeah, right.
Yeah.
You either have, right. Yeah, I see what you're saying. Two arrows pointing away with the edge in between, and 2 arrows pointing the same with an edge in between.
Okay, so my other option was to go with the flow on one of them. So I chose a side that could go either direction.
Yeah, you chose a side that could go either direction.
Oops, I didn't mean to take off my first one. Put that one back. Oop. Oh, I keep moving it. Why is my pen not drawing? There we go.
Okay. Do you want me to keep my move the same?
Sure.
Oh, mine's doing it too. I have to click the pen again.
Okay, so now I'm not going to go on that bottom right. So I need to go with the flow on one of the others, and it doesn't look like that matters which one.
Okay. So I can either go with the flow on this one or this one. I don't think it'll matter because no matter what I do, you're not going to be able to move next.
Right. So you would have, by doing what you did, looks like you would guarantee the win.
And even if I chose the bottom one,
Right.
I would have still made the last legal move.
Right. So by doing what you did on your first move, you guaranteed the win.
Yeah. So as long as the second player played strategically,
Yeah.
because she could have done something else, right? I mean, she could have played an adjacent.
Yeah. Well, would it have mattered if I was strategic on? We could try.
Yeah,
like if I
is
just
there a
was
way?
like,
Is there a
oh,
way
let's
for
make
you
a
to lose?
circle.
Yeah, I'm kind of thinking
Yeah.
she
Is
may
there a
not be
way for
able
me
to
to
lose.
lose if I go second?
Yeah, let's see.
Okay, I'm gonna try not to be strategic.
Yeah, let's see if we can make player two lose on an even sided. Because on a
Okay.
quadrilateral, I'm realizing, thanks to Chris, that there is no way player two can lose. No
Yeah.
matter what, player two has to win. No matter, like, there's no.
Yeah.
Just like on a triangle, player one has to win. There's no.
Yeah.
Okay, so so there's my move. We'll just stick with that same
Okay.
start.
I'm gonna not be strategic at all and just follow suit on the next one.
Okay. So you had, okay. I was just trying to think of if this is going to take care of all possibilities. But the other thing we haven't considered is you going on the side opposite. But I like this first. All right. So I could go at the top and keep the flow going. I could go here and mess things up. So let's try that. But when I do that, I eliminate a side from ever being played by either one of us.
Oh yeah.
So I think that it does seem that the parity idea is coming in.
And then Jessica, like once you do that, then Jessica's going to win no matter what.
Yeah.
Mm-hmm.
Because she only has 2 edges, and each of those edges, she can only draw the arrow in one direction. She only has 2 moves, and either of those moves, she's going to win.
Yeah. So my second move so I'm going to undo that a second. If I had gone with the flow here, well, that doesn't, yeah, if I keep going with the flow, then obviously you're going to win.
Yeah, because there's an even
Sorry,
number of
that
sides.
was
wait,
the worst
Jessica,
arrow.
can you do something that's entirely not strategic? Like is there
What?
any way for you to lose, like in this case?
Let's try your first move is on the side opposite.
Okay.
Oh, did you?
Well,
I can't hear.
Y'all said
oh,
my
there we
internet
go.
sometimes is off.
No worries, get back.
Okay, so we are parallel opposite side. So I can, interesting. No matter what side I pick, there's only one direction I can go.
Yeah. No matter what you do, like you have to draw the arrow in the width.
And would that have been true had she, that would have been true had she
Yeah.
gone the other way as well, because there's only 4 sides remaining and they all have, okay, so we'll just try this one.
Yeah. So Jessica would win now, right? I think
Yep.
I think we lost her again, but no matter what,
Yeah,
because that edge is now out. And
right.
this edge has only one possibility, and that edge has only one possibility.
We haven't proven it, but on this one, but pretty close.
Yeah,
And
seriously, that is wild. Huh.
So when she did, so if she had gone with the flow on her first move, that wouldn't have made any difference. Because again, I would have to do,
Yeah. So, and if you just go around, of course,
right, then the second person would have to win on this
the
one.
second person would have to win. Yeah. And so I guess the point is if you go around, then the second person has to win. And if you don't go around, like,
Well, to me,
what
it
if-
looks like the second person wins no matter what they do. They don't even have to be smart about it.
yeah, right. That's what it seems like to me too. Hey, Jessica.
Hi.
Like, so
My
what if,
internet went out completely that time.
what if the second person does that?
I think we did that.
And then, so Mark, if you play something that is not in the right direction, that is not with the flow on either of the 2 opposite sides, then
she can go with the flow on either of those other two and win.
Okay. Wow.
So when I'm moving my mouse right now, do you guys see me doing that?
Mm-hmm.
Okay.
Mm-hmm. Yeah.
Which is okay in this like small setting, but in the group setting is annoying.
Yeah, it's too. I know. It's so weird that you can't turn those other cursors off. Like what?
And at first, when you're like, go to the corner, I was like, oh, they're doing it, and then
It's because you don't see. It wasn't even showing your mouse. Basically, I think that's why people weren't realizing that they were
where your cursors were.
I don't think they realized.
It doesn't show your cursor; it just shows everybody else's.
Yeah. So, but in this one, it's showing me a plus sign.
Yeah, I see. So you didn't see the plus sign.
No, not so. I think that's why people were still stuck in the middle.
Gotcha. Because they had no. Yeah, that is super weird.
All right. So should we extend this to more sides, or are we ready to start putting lines down the middle?
I'm feeling more confident about my conjecture, so we can start putting lines.
Okay.
Do you want to start with just one?
I want to think about, but can we provide reason as to why that the conjecture is true, not just by exhausting all the examples, but by, I'm not saying we need to answer that question, but that's just a question I have.
Yeah. The simplest is if there's an even number of sides and everyone goes with the cycle or the circuit or whatever it's called, then of course the second person will win. It's when they go against, kind of like what you were saying, that eliminates a side.
So I'm eliminating two sides because I'm eliminating the one that I wrote on and another one.
If you go against the grain.
Right.
So if you go against the grain, you're eliminating this side. You're eliminating at least two sides. You're eliminating a side in between the two arrows in both directions.
Right, but that doesn't happen.
Yeah.
But that didn't happen if I went on the side. Oh, on my move it did, yeah. But on your second move, if you went on the opposite side of that hexagon,
yeah,
only the side you drew on was eliminated.
Well, I just count that one as part of my move, but
right.
So
I think
you go against the grain.
You're eliminating three sides. So if you go with the grain, you're eliminating one side because nobody can draw an arrow on that side, right? And if you go against the grain, you're eliminating three sides because you're eliminating the side that you drew on.
Well, you haven't eliminated the
two other sides. Yes.
Plus two other sides because there's a side in the upper region that will eventually not be possible and a side in the lower region that will eventually not be possible if you go against the grain.
Right, but yeah, you're not
which won't change the odd or even when you
right, the oddness or the evenness.
Yeah.
Okay. Sorry, Mark. What were you saying? Does that?
No, I think you guys were. I think you're saying the same thing. The only thing I was going to add was, or not really add, it might have been subtracting, unfortunately, was that when the second play was made on the opposite side of the hexagon, all four sides left still could be moved on. But the direction was determined. But the direction was determined on all of them.
Right. Mm-hmm. Right. So once you so the second player, so at any move in a polygon, I guess I think is every time you move, you're always eliminating the side that you moved on because the player can't play on that one. And if you go in the grain, you're only eliminating that side. But if you go opposite, you're eliminating not just the side that you played on, but ultimately
two directions,
two edges on either side of the one that you played on. It may not happen right away, But ultimately, there's going to be, if you go against the grain, you're going to be left with, like on this in a 6-sided game board. If you go against the grain, only four edges will be able to be played on.
Mm-hmm.
And if you go with the grain, then all 6 edges can be played on. But you're not changing the parity of the board, basically.
Right. So I'm trying to think if this would even work. When you start the game board on a hexagon, I had 12 choices.
Mm-hmm.
Technically, it didn't matter because as soon as I start the direction, then that's what.
Right.
It doesn't really, like
what
you
I
did,
do, the first
like
move
it
it makes no difference on a polygon. So, but I'm eliminating 2 of the moves immediately because I've chosen that side. So you can't go on that side again. And then I'm also eliminating 2 decisions on which direction you can go on the 2 sides adjacent to it.
Totally. But you haven't eliminated any edges. Every edge is still technically playable. Like,
right.
When you go first on a 12-sided polygon, 12 sides are playable. After you play, 11 sides are playable.
Well, no, but on a hexagon, I have 12 arrows.
I see.
12 arrows that I can make. And on my first move, I'm eliminating 4 of them.
Right.
Yeah. It's after that first move, that's when things can happen. And if you go with the grain, we're saying that the number of edges that you can play on stays the same. Like, you're not going to cause an edge to not be playable when you go with the cycle currently being played.
Right.
It's when you go against. So when you choose that arrow that goes opposite, that's when like some of the edges, so your choices are eliminated. Now, whether those are with or against doesn't matter because it'll still be even because it's an even number of sides. So whether you had 2 choices or 1 choice is irrelevant since it's still an even number of choices.
Yeah.
Yeah.
Right. So if we only think about, instead of how many possible moves are there, how many possible edges are playable, then the parity for the first player, like every time you play, you're not changing the parity, basically.
Right.
It's either goes down by 1 or by 3.
Mm-hmm. Okay.
And is that true for both players?
I think so, because if you go with the grain, provided everybody goes with, right? So, right, if all the arrows are going in the same direction and you continue that, then you've just cut the number of edges that are playable down by 1 because you played on it.
Yeah.
But every other edge is technically playable. But if you go against the grain, you've cut it down by 1 plus at some point 1 in between on either side. So you've cut it down by 3, regardless of whether you're player 1 or by player 2.
Okay. So do we need to take this to a 7 or an 8 to see what's?
I think that that satisfies me. I mean,
okay, I'm good. All right. So what kind of creativity do you want to have?
Let's do a 4-sided figure with 1 line through it, right. Which is just slightly more complex. Will it have any, like, is this kind of related to game theory, or I'm trying to think, or not game theory, but like graph theory? I haven't done a lot with graph theory, so I really won't know anything.
I think it's probably both.
Yeah, probably. Game theory I did in college, but that was a while ago. Yeah.
All right, okay. So Mark, you want to do this one where it's just a quadrilateral with 1 diagonal?
Sure. Because we can't do a triangle with the diagonal.
Yes, indeed. So the next simplest shape is a quadrilateral with one diagonal. Okay.
I guess what would, if we just did a line segment?
Then I guess the first player.
Now, one thing I was wondering about is if you had a tree diagram.
Yeah, because that's possible.
I mean, you would never get the cycle, but still to be the legal last move thing going on there. But anyway, let's not go there yet. All right,
but at least for a 1 and 2 sided, for a tree with one edge and with 2 edges, our conjecture still works, right?
Right.
1 edge is an odd number. First player obviously wins. 2 edges, the second player obviously wins.
Right.
Yeah.
Okay. You want to go first or second on this one?
I'll go first.
Okay. Since there's an odd number of edges.
Yeah, I'm just like seeing if it'll happen.
Okay, so I know I don't want to go in the same direction on the 2 other parts of the triangle, because then you can finish it.
And yeah, I can win.
So let's just try. So I can do this. Here, let me make that clear.
Mm-hmm.
And so that's what I asked that question. I didn't realize at first, I thought this would already be considered illegal, but because that third side, it's not.
Right. Yeah. So if I did the middle one, I'd have to go down and then you could win.
Mm-hmm.
And if I did the one on the right, I'd have to go with yours and then you could win. So you would win. Right?
I think you're correct.
Okay,
So is it the fact that there's 2 triangles?
Yeah. So it's like the second person, like, yeah, that's totally it. I think it's like now it's like you're Jessica, you're player 2 in a triangle game. No matter what you choose, you're player 2 in a triangle game, and player 2 is going to lose.
I think we lost Jessica again.
Oh, but yeah, Mark, I think that's right. Like,
so what would happen had I gone on the same side, but with the flow?
I think it's the same, right? I mean, it's still 2 triangles. If you, provided you didn't go on the same triangle. Right.
Because then she automatically wins.
Okay.
So it's like I'm making, yeah, I think I see what you're saying now. So I became the first player on the second triangle.
Right. And now there's only.
And now she has to be the second. She has to be the second player on
a triangle.
On a triangle.
Yeah. So if you had been, it's not deterministic though. Like, in other words, if you had been non-strategic, it's possible Jessica could have won.
Right.
Right, by playing
in the same triangle
in the same direction.
So that's interesting, because going back to the pentagon that you were playing, that you drew in the opening session, there was a triangle and a quadrilateral.
Mm-hmm.
And I don't remember what order things happened, but once someone went on the triangle, you did not want to be the second player there. So those 2 sides had to be avoided.
Yeah, that's a little more complicated though, because
you have 3 vertices coming out of some edges and 2 out of the others.
Yeah. Let's try that.
Do you see that? I put the
Yeah.
drawing at the up
Yeah.
above.
Yeah. All right, I'll be player 2.
Okay, so I'm going to start. Since I'm an odd, I'll start on the triangle because I think that sounds like a good strategy based on our other stuff.
Yeah. Okay, so now what would be not smart for me? So I'll do this, but oops.
Oh, you can go opposite direction on that triangle. Yeah.
Yeah.
So that
would be not smart, right?
Right. So
Okay.
then I would win. But you
But I
can
could-
go on this side up there,
Right.
and I
but
could have.
do that, and that won't necessarily make you win because.
Well, that will. What you just did
yeah,
will.
sorry. This way.
Right. So now.
Like if we were playing a triangle, if we only had that triangle, you would have won right there. But since we have all those other things, you haven't necessarily won yet.
So I can go on the bottom and it won't end the game.
Yeah.
I'm going to go ahead and try that just to see what happens.
Okay.
But see, then now you become the second player on a quadrilateral potentially. Yeah, I think that's
exactly what's happening. Like now it's a quadrilateral and I'm player 2, so I'm going to win.
Yeah.
So you don't want that, right?
Right. So let me undo that. So
now you get player 2 on a quadrilateral.
Right. And I need to make it so you can't. How about it? I don't think I can. I was going to try to restrict that if you went back to the triangle, because I want you to stay on the quadrilateral.
Right. Totally.
However, see, if I go on this side here, I can still go either direction.
Yeah, totally. If you point that.
So I'll go with the flow just to see.
Oh, I was going to say, if you go opposite the flow.
Okay, I'll switch to that. If I go opposite the flow, I think I lose my advantage.
No, I think you win because. Oh, wait.
No, because you can make a legal
still
move.
Play on the triangle. Sorry. I see what you're saying.
Oh, and you can also go on the quadrilateral. Because you can.
Yeah.
So if I'm going opposite direction here, I mess up the quadrilateral part. Oh, wait a minute. Now that I did that, though, let's go ahead and finish this. I think, because right now you can't play that bottom side of the triangle.
Can't I? Because can't I do?
Because it'll be a source either way.
Oh, yeah. I can't go there because of that. Right?
Right.
And I can't go the other way. Aha. That is a good strategy. Whoops. I see. So once you do that, you've eliminated the triangle. And now you're player 2 on a quadrilateral, so you're going to win.
But I went against the rules on the quadrilateral when I was player 2. Because if we had had just a quadrilateral, I couldn't have done what I did.
Right.
So let's see. You, on the top side, you could go either direction.
Okay, so if I had chosen, so in this case, you're going to win no matter what, right?
I'm not sure yet, because if you go up on the top left, if you would go, because it's your move next, right?
Yeah.
if you would go to the
I can
right,
only go one direction there though, right? Because I can't
right.
can't go to the left on that one.
See, and I think you win when you do that. I don't think I can move.
Oh, if I do this,
Yeah. Because I'm going to have a source at, or a sink. I mean, I'll have a sink if I do this.
I see. So the thing that I see what you were saying earlier. So the thing that you drew, we can't think of that as a quadrilateral because the thing that you drew is illegal in a quadrilateral.
Right.
It's only legal because there was that other thing there. So it's not that this is just a triangle and a quadrilateral.
Right. Because it
slapped
goes
together.
back to the idea that how many ways that I can draw the arrow am I eliminating with a particular move.
Right.
So now I can't remember. I went first on this. Let's go back. Let's each remove our last moves.
Okay. Oh, somehow it's always removing more than one move for me. Okay, so I was like, that's how we were before, right?
Yeah. So I went towards that and I guaranteed you winning because you only had one move to make. So what if I went with the flow?
Yeah. All right. So now
You can still win.
I can still win?
I think so because, oh no, maybe not. Yeah. And the reason is because if you go in that bottom,
Yeah, I have to go in the bottom. If I play the quadrilateral,
then I can finish the quadrilateral.
I have to go with the flow and you'll finish it, right?
Yeah.
But likewise, if you have to play the next move in the quadrilateral, then you'll have to go with the flow and I'll finish it. So what I have to do is make you play the quadrilateral, right?
Yeah.
So if I do, oh wait, can I though?
Yeah, you can play down there now because
If I go, I see I could go this way.
yeah, actually you can go either way, I think.
If I go the other way, then
that other one was right.
Is a source, but I can go that way.
Yeah. And so now I have to go with the flow because this guy, our first two moves are forcing the direction of that quadrilateral.
Right.
So no matter what I do next, you'll have the last move.
Right. Okay, so so in this pentagon with a line, in the pentagon with a middle edge, let's call it, if you play an outer edge of the triangle, you'll lose. Like I can be strategic and win.
Right. Right. So now we need to, if I start.
Yeah, let me clear out my.
Oops, I cleared out too many. Let's put it back.
Yeah, okay.
All right, so now the thing I didn't do the move.
Yeah, that seems to be a really strategic. Yeah, okay.
And does it matter at this point which direction I chose on that? I wonder.
I don't think at this point it matters because all you're doing is setting like, in other words, that has, mirror
Right.
symmetry. So.
Right.
Let's see. Okay, so if I play, so I have all sorts of options now, right? It's not clear. I'm just going to play something that's not clear what is the good strategy here, but I'll just do that.
Okay, let's see. So I don't want to play this side over here. I can't go towards
Because
make
if
it a
you played
source.
that side, you'd have
And
to go with the flow.
And then you'd finish the
and then connect
triangle.
it.
Right. Down here, I just don't want to go with the flow.
Yeah.
And I'd be okay, at least not die right away. Let's see.
So we basically, by me going the way I went, we removed the quadrilateral from being a cycle.
Correct. Interesting. So I can't go, if I go with the flow, you'll win, and I can't go the other way there. So this side, I don't want to go with the flow. If I went away.
Yeah, so I think if you go away on either your best move right now is to go away from the flow on either the quadrilateral or the triangle, right? Then you at least don't guarantee a win for me.
Right, so I'm going to do what I did there. I don't know.
Yeah, that seems... Okay,
Oh,
so
wait a minute.
now this edge is out, right?
No, but it's a legal move. You could still
Well,
make a legal move there.
On this edge?
Yeah, it won't. It'll
Yes.
keep it won't force a sink or a
Oh, I see. I could go this way.
right. And then if you do that, that's not good for me.
Is that right? Oh, I see, because each of those edges you can only play one direction on. You have to
Right.
go with the flow for each one.
Yeah. Yeah, I think so. Would it have made a difference had I done something in a triangle before I did that first move on the...
Yeah, let's undo those last couple. Okay, so I was like that.
Yeah. So if I was here and did this, would that make a difference?
Right, okay. So now I could do this, right? No,
Yeah.
I can't do that.
Yeah, you can. Oh no, because it made that a source or
Yeah.
a sink. I mean,
Yeah. So I think that edge is
I just
out.
eliminated this guy here. So I think that just changed the. Did that just change the outcome? Oh no, because you can be strategic.
Can I?
Yeah, you can. I think I see how you win.
Yeah, so if I go, I mean, either edge, I can only do one move, right?
Yeah,
Like if I play this edge, it has to be this direction,
and then I can't play.
and then you can't play, right? And okay, so then I would win. But if I do the other edge, it has to be this direction.
Right, and I can't play.
Yeah, so it's like I'm creating essentially a parallelogram either way, right? Like,
So let's see that you were the
player.
second player. Okay, so that means that no matter, I don't want to start with the triangle. I know that much.
Yeah.
Because we just eliminate. I think we eliminated everything.
Yeah, I mean, it doesn't matter what.
Okay, so let's
So
try
many
it.
cases in this one.
Yeah.
It's complicated.
All right, Jessica, we think we determined. Actually, I'm not convinced anymore.
So did y'all? I know I tried a couple like quadrilaterals with one line and I got ways where either player could win, but it depended on their moves.
Right. But
But
but if you play strategically, can either person guarantee a win? Because
I don't think so.
when
I
you
don't know.
made that,
I did one on the side and then you did a top and that guaranteed your win.
right.
But you didn't do the diagonal. But then I tried another one where the first player went on the side and the second player went in the middle and the first player was able to win.
Uh-huh.
And then I tried one where the first player went in the middle and the person could win after that, depending on moves.
Or you said either one could win? So let's play that game to see if we can determine. And then I think that then we come back to the triangle quadrilateral thing. So let's go back. Actually, I'll just draw a new one. Or so I thought. What just happened?
I drew a really tiny one.
Get rid of that. Try this again. There we go. I don't know if you can see it because I kind of did it off of the side a little bit. Oops, now it's moving it. Okay, so you were the first person, right, before?
Mm-hmm.
All right, so what happens if you go on that middle one? And it shouldn't matter which direction.
No, it shouldn't matter which way.
Okay, so I know that of the 4 sides remaining, I do not want to go with the flow.
Yeah, because then Jessica can complete a triangle.
So I need to go against the flow.
And it shouldn't matter which one you choose. Any edge against the flow is the same as any other edge, right?
Yeah, I would think so.
Because I'm eliminating.
All right. I didn't write down the ways, unfortunately, but I know I was able.
I think you only have one move here to stay alive.
Is it staying with the same triangle? It would be, wouldn't it? Like I'd have to go here.
Oh, maybe. I think you could have gone over here too.
But then you could have completed it and you would have won.
Right, but you could have gone either direction.
But now, Mark, you're the second player in the triangle now, Mark, and Jessica's going to win.
But maybe. Oh, you're right, because they're both going in and out the same way. Yeah, so there I can't move on this side and expect to win.
Mm-hmm.
Yeah, and I only can go with the flow here. Okay. Now, so did I have another option on my...
Like after I went to the middle?
Yeah.
I don't think so, because you couldn't have gone with, you had to go against the flow.
Right. But would it have made a difference?
Right.
Okay, so let me try against the flow up here at the top. Just
so maybe that does guarantee the win. I don't know.
Kind of, yeah.
As long as you're strategic. Yeah, so if you go against the flow here, I mean, if I go with your flow on this side over here, I'm guaranteed to win.
And right.
But
so no matter what you do, Jessica can play on that triangle that you played on, Mark.
Yeah.
Well, let's see. So play on that triangle, and let's just see if that really does guarantee that Mark loses.
The same one?
Yeah.
Okay.
Because the conjecture is like that now, Mark.
And you had to go that way because you couldn't even go the opposite direction.
I could not go the opposite direction, right?
So now at the bottom, I cannot go to the left. And if I go to the right, I'm with the flow. On
And
the
I win.
left, I can't go up. And so I'm with the flow. Yeah.
So
So
I just
player,
guaranteed myself a win.
right. Yep.
So if you're the first person playing that game strategically, you should go to the middle.
Right. So there's a winning strategy for player one.
Yeah.
Yes.
And it's taking advantage of being the first. Basically, you're the first player on both triangles.
Yeah.
Right. Yeah, because it's a shared side.
Okay. So Fred, do we know what's going on the triangle with the quadrilateral? Or the pentagon with the the one line cutting through?
Yeah, y'all went ahead to that. I didn't even think about exploring that yet. I'm just like,
Yeah, we
would
skipped.
it matter where the line was on a pentagon? Because there's multiple ways you could put that one line segment. Or would it not matter? Because there would still be 2 and then a 3. So
Right.
maybe it wouldn't matter. Okay. I had to convince myself.
Yeah. So player one was the winner in that other one, if things were strategic.
Right. So it's not deterministic, though.
Right.
Let's see what we got in the gallery here. Fred's sometimes hard to pull away from the table. Were you deep into a conjecture, Fred?
Super deep. That was intense. I was like, go away, announcements.
Well, I thought it'd be good just to come back together for the last 5 or 10 minutes here and see what sort of consensus people came to about anything. So if we open up the gallery here, it looks like table 8 might have so there's definitely people playing around with polygons, regular polygons, and table 8 might have a deductive argument for why a polygon with no diagonals is deterministic. Can anybody from table 8 chime in for that? Who was that? Anybody from table 8 willing to join us in present mode and talk about that?
In case you forgot your table number, table 8 was the people with me.
Oh.
But I don't. There's Mark or Jessica.
Oh, okay. We can bring
or somebody else. If somebody else has an argument for about a polygon, it doesn't have to be our table. We happen to come up with one, but
we can bring people into the present mode with us, right, Terry? Yeah.
Yeah, because each vertex has to have one in and one out. Huh, that's interesting. I wonder. Yeah. Our argument was based on counting edges, but I think it has to do with the one in, one out rule.
Here's an interesting question at the beginning of the gallery. Given any planar graph, what is the least number of moves to determine a winner if both players are strategic?
Yeah.
I like the picture of this last board in here. This is I don't know, our group found that we weren't doing any really complicated boards. We started out with regular polygons and then took regular polygons and put a chord in them between 2 vertices. And we didn't get much further than boards that had like 3 cells on them. Maybe played a couple games on a 4-cell board. Did anybody find a particularly interesting or fruitful board that they felt like they could wrap their head around that wasn't a regular polygon? I see this last piece here for the quadrilateral with one diagonal is not deterministic, but player one has a winning strategy. Did you put that, Fred? Yeah.
Yeah, but Stephen, can we bring Stephen Alexander? So we did 2 triangles with one vertex.
Yeah, Stephen, do you mind being brought in?
Just share what you discovered with those.
Yeah. So Stephen, if you share your camera or your mic, it's up to you. If you turn your mic or your camera on, you should be able to share with the group now. Thanks.
The problem is that we did analyze it, but I don't remember the analysis. I'm sorry. It was
That's
fun
fair.
analyzing it. Yeah, maybe choose someone else from my group, table 14. You know, the only useful observation, and I'm sure everyone made this though, is it's nice when you see symmetries that you can eliminate things you have to check. Lots of symmetries. You know, I guess you could call it a bow. What we did, a bow tie. Obvious symmetries there.
Yeah, right.
Sandy
So I
said,
think I'll bow out.
okay. Sandy wrote that overlapping hexagon with 4 diagonals. For an interesting, fruitful board. Maybe we can bring the whiteboard back for everybody. Sandy, could you draw what that board looks like in the whiteboard for us?
I think we have to make her a presenter. Did you do that?
Well, I think since we're in the main whiteboard, everybody's cursor is in there. Yeah, it looks like Sandy's drawing in there.
I see. So Sandy has a cursor, but does she have tools to draw with?
I'll bring Sandy in. Sandy, if you want to turn on your mic or see if you can draw on the whiteboard.
Yeah, I think you should be able to draw on the whiteboard now, Sandy.
Oh, she said no. Oh, well.
Okay.
Well, thank you all for playing.
Hi,
Hi.
Yeah, I don't have any tools though on the whiteboard. They were just the hexagons overlapped, so we had a diamond in the middle.
Oh,
And then we took a diagonal from one side of one top corner hexagon to the bottom corner of the opposite hexagon, both sides, and then just short diagonals to make little triangles on top. So we ended up with a bunch of places we could do cycles, but
cool.
anyway, we didn't determine a winner because it was towards the end. So
All right.
that's an interesting shape, though. That's cool.
Yeah. Fred, do you want to talk about the history of this game before we close out here and how you came across it?
Yeah, right. Well, I think the game has a longer history than I know, but I was made aware of this game so this game I think was invented by a mathematician named Francis Su, who's a former president of the MAA, the Mathematical Association of America. He teaches at Harvey Mudd, and he just wrote a lovely book. Probably a lot of people know it, but it's called Mathematics for Human Flourishing. I'm going to type that. Mathematics for Human Flourishing, and he shared this game. He shared this game in that book, and he also shared it in a Twitter thread, which is linked to from the at the top of the document, at the top of the gallery document. And it sounds like from talking to Brianna, he had been exploring this game a little bit with other folks even at AIM, even before that. But anyway, so this game is invented by Francis Su. It's super simple, as we saw in the chat. It's super simple to play and learn, but it seems awfully complicated once you get into it. And if you do click that link at the top of the gallery, the rules of the game link, it takes you to a Twitter thread by Francis Su. And he and some collaborators have actually written a paper about it. And at the very bottom of that Twitter thread, you can find that paper. Nick and I have not read that paper because, as we said, we wanted to we wanted to come in here fresh, but it seems like they've made some interesting findings and have some interesting questions that are yet to be explored. So
Yeah.
That's it.
Well, thanks for all coming tonight. I hope you found this object of interest, and maybe we'll see you at some future sessions later this week.
Yeah. Thanks, everybody.
Yeah. Have a great night.
Cheers.